So you probably saw this one coming. They want you to make log rules like they did with the power rules. And given that they're similar because you're dealing with exponents and the patterns should be kind of the same-ish, then it makes sense that we would have some kind of a pattern for a logarithm because it's just the inverse of an exponent, and the exponents have laws. So what they want you to do for this one is they want you to play with your calculator. And it says you're supposed to go log 2 plus log 3 equals log what? Well, that's not going to actually work in your calculator exactly like that, but there's a couple of things you need to know. First of all, if you use your calculator and you hit the log button, you are using log base 10. So if you wrote it in, it would be log base 10, log base 10, log base 10. And that's what your calculator is giving you. So it's nice to be aware of that. The important thing in this case is that it's the same base. We don't really care what the base is, the same way we don't care about the base when we're doing the exponent laws. We just care that it's the same. And so they're all 10. Yay, it works. Now, if I grab my calculator, and I'll show you, I want to hit my log button. See, it says log. I'm going to hit my log button, and then I go log 2, close bracket, plus log 3, close bracket, and it gives me this 0.77815, blah, blah, blah. Don't really care about that. It's just that we want to find a log that equals that same number so we can develop the rules. So you could go, well, what if I went 2 plus 3? Log 5. Let's see if log 5 equals that. Log 5. Nope, that doesn't. But you could probably even think about the exponent laws, and when they're adding, they're multiplying. So let's try 2 times 3 is 6. So let's try log of 6. There it is. So we can just take a quick break here and write in that it is log 6. So we can develop the rule then that if we have the same base and we're adding logs, we can multiply these numbers to get the final answer. Kind of like the inverse of when you do it with exponents. So here we've got subtraction, so you might even go, you know what, I bet that's division, because subtraction, division, multiplication, addition, seeing patterns. So you could guess that this one, log 8 minus log 2, might equal log 6. Or sorry, that would be subtraction. 4. So 8 divided by 2 equals 4, the same way as 2 times 3 equals 6 up here. So we can use our calculator again. And we can clear all this stuff off, and we can go log 8, close bracket, minus log 2, close bracket, equals 0.602, whatever. So then I decide to check my theory, and I think it's going to be log 4. So I'm going to try log 4 equals, whoa, look at that. I was right. It's like I've done this before. Now, let's have a look at that last one. 3 log 2 equals log what? This is 3 times the log itself. So it's more complicated than adding or subtracting. I'm going to throw out there that the other rule for exponents that they reminded us of was the one where if it was raised to a power, you multiplied the exponents together. So how could we do this? What if we reverse that one, and where these guys look like they're being multiplied, we actually expressed it as a power? So let's try and test 2 to the power of 3. So let's see if that is going to help us get the same answer. So over here again,
I want to go 3 times log 2, figure out what that is.
So that's the number that I'm looking for.
And let's see if I get that number by going log of 2 to the power of 3.
Yay, there it is. Same number. So we're kind of using the exponent laws backwards, and we're coming up with this sort of thing. So this one does go here, and we've just established 3 new rules with logarithms. If I'm dealing with the same bases and I'm adding the logs, I can take the numbers and multiply them to get the final answer. If I'm subtracting with the same bases, I can take these 2 numbers and divide to get the final answer. If I have a wonky one where they're making me multiply, then I can raise this number to that power and get the final answer. So it's kind of the inverse of the exponent laws.